Hola, ¿qué tal? ¿Cómo se encuentran? Muy bien, buenas noches, ¿cómo se encuentran todos? Ya estamos en vivo. Muy bien, veo que ya hay gente conectada, escribiendo, emocionados por la plática de Alex. Perfecto. De Oaxaca, Colombia, México. Uy, de lujo, muchas gracias por acompañarnos. Perfecto, todo va bien. Pues buenas noches a todos, gracias por acompañarnos. Estamos hoy en una plática muy especial para todas las comunidades de México y toda la gente que se ha unido a través de Latinoamérica. Hoy tenemos un super invitado, Alex Debris. Seguramente han escuchado mucho de él este año. Escribió lo que parece el libro del año sobre AWS. Él nos viene a platicar muchísimo sobre DynamoDB, buenas prácticas y todo lo relativo a su libro. Yo sé que DynamoDB es un servicio que muchos están ansiosos de conocer o de profundizar su conocimiento porque parece que es un servicio que es un arma de doble filo, ¿verdad? Lo haces muy bien, te va muy bien, o te metes sin conocerlo y te puede ir un poquito mal. Precisamente es una gran oportunidad para poder aprender. Y bueno, de lujo, ya estoy viendo a todos. No se vayan, acuérdense que hay que registrarse. Por ahí se les pasó un link para que se puedan registrar. Y más adelante vamos a tener a Alex haciendo un par de preguntas para que podamos rifar unos libros que nos va a regalar a las comunidades. Entonces está de lujo. Hay muchos fans el día de hoy. Perfecto. Bien, pues a nombre de Gabriel, hoy Gabriel no pudo estar en la sesión. Se va subiendo Gabriel, me hace quedar mal.
Ya llegué. ¿Qué tal? ¿Cómo están?
Bien. Hola, Gabriel. Hi, Alex.
Hey, how's it going?
Hi, Alex. How are you doing?
I'm doing well, thanks. Thanks for having me. I'm trying to get my mic to work, or my camera. Sorry, sometimes I have trouble focusing it. I think because I have nothing behind me in the room, so it can't pick me up. But
sure.
I'm to focus here. Thanks for having me.
Thank you so much for accepting this invitation to speak with our AWS communities. We are so excited. So I believe DynamoDB is one of the most amazing services offered by AWS for developers, and I believe that DynamoDB is on the center of every well-architected, every well-designed architecture. So there will be a lot of questions from our audience, which is really nice. So, well, thank you so much, and we will be delivering a couple of your books. So that's great from your part. Thanks so much.
Sounds great. Yeah, excited.
Yeah,
excited to do it. Cool. Want me to hop in?
Yeah, I think so.
Okay.
Yeah.
So we can start. Okay.
All right. Can you all see my slides?
There it is. Yeah.
There we go. Okay. Sounds good. Glad to be here. Happy to answer questions, whether that's during the talk or after. I don't know what sort of works best. So just let me know what works best. If you can stop me if something's confusing, feel free to. I tend to talk kind of quickly. I'll try and not do that, but feel free to ask any questions as we go. So yeah, just to sort of, before we get into it real quick, what I want to talk about is what we're here to talk about, and that's Amazon DynamoDB. I want to talk about a few of the reasons I love DynamoDB and how I really got into it. So the first thing is that it's very serverless friendly, right? So this is how I got into it. I worked for a company called for Serverless Inc. that made a tool called the Serverless Framework. And DynamoDB really works well in this serverless world with AWS Lambda, with this really ephemeral compute. It works really well with infrastructure as code, with the IAM permissions, all that. So it just fits really nicely into the AWS ecosystem, in that serverless ecosystem, as compared to a traditional relational database or even something like MongoDB. So I think you're really seeing people, because of all those benefits, because of its billing model and its scaling model, choose to use it with serverless, which has been really great. The second reason that I like DynamoDB, and I didn't really know this at first, and I've really come to appreciate it over time, is that it has really consistent performance at any scale. And to show what I mean by that, I want to show a little chart. So here's a little chart I have. On the x-axis there, I'm just going to talk about how much data you have in your application. And these are just rough numbers, but you start with a gig at when you're testing locally, or maybe you've just deployed to production and have a few users, and you move up to 10 gigs and 100 gigs, and finally you're at big scale, you have a terabyte, something like that. And then on the y-axis there, I want to show performance, right? And at the bottom, we have blazing fast performance where everything's returning really quickly, and then it's fast, and then it's sluggish, and finally painful as it gets sort of slower as you go up on that y-axis. If you're using a traditional relational database or even something like Mongo, your performance is probably going to be something like this, where it sort of scales up over time. When you deploy initially or you're running locally, you're loving it because it's working really well. You don't have a lot of data; it all fits in memory. Response times are great. But then you start to scale up. You get some more users. And now it's starting to not perform as fast. It's moving into that sluggish mode, right? And you have to go investigate it. Maybe you have to add some more indexes. Maybe you need to denormalize your data a little bit or take away some access patterns that you previously had. And then finally, if you get to some point where you scale up high enough, you might actually just have to re-architect, right? It's become painful, and some assumptions that you made down at 1 and 10 gigs just aren't working anymore at a terabyte, and you have to re-architect how your data works. And this is a pretty traditional pattern you see for people as their databases scale up. By contrast, this is the performance model you're going to see for Dynamo. It's going to be basically flat. You're going to see the exact same performance at low scale as you have at high scale. And if you look at the very left side of that chart on the beginning of the x-axis, you might notice that MySQL or Postgres might be faster than Dynamo. If you only have a gig of data, although it's probably not going to be perceptible to users. They're both pretty quick in those instances. But the real key is when you move further right on that chart, you get to 100 gigabytes, you get to a terabyte, you get to 10 terabytes, you're gonna get the exact same performance patterns at those scales that you got at 1 gig and 10 gig. You don't have to go back and sort of re-architect your data all the time. You're gonna get the exact same performance characteristics. And that's pretty awesome, and it just really frees you up to keep moving forward and making progress on the new features you want to deliver, rather than sort of having this support burden and maintenance burden of these existing access patterns that you're handling there. So I think this is a really underrated point with DynamoDB. We'll talk a little bit more about why this happens, why those performance characteristics, but I really love that about Dynamo. So that's the second reason I love Dynamo: consistent performance at any scale. The third reason is just the continued innovation from the Dynamo team, and they've really done a great job here over the years, and they haven't just sort of rested on their laurels after releasing this great thing. So I just want to cover a few features from the last few years and how they've really changed the game, even in this already amazing database. So at reInvent 3 years ago, this was November 2017, they came out with 2 new features. One is global tables, and what this means is you can have primary databases in multiple different regions. You can have it up into 10 or 15 different regions if you want, and a write to any of those regions is going to get replicated to all the other ones. So you can just have primaries all over the place, really close to your users, and not have to worry about that syncing problem. They're going to handle that for you. Likewise, you can do on-demand backup, where you can make a backup and it's immediately available for you, and that just reduces some of the ops burden that you're going to have there. Next August, 8 months later, they add this thing called adaptive capacity, and this is pretty interesting. What they used to do is, you would provision your sort of capacity, how much throughput your database could handle, and generally, if you had some items that were accessed more frequently than others, you sort of had to over provision your capacity to account for those, rather than if you had like an even access pattern. With adaptive capacity, they really limited the need of you to do that, where they're going to sort of spread that capacity where it's most needed. So if you have some data that's accessed more frequently, they're going to do that, give that capacity there, and then the items that aren't really read, they'll take capacity away from that. So that really made it a lot easier for a lot of folks there. And then that reInvent in 2018, this is 2 years ago now, they came out with 2 really huge features again. Number one, DynamoDB transactions, where you can operate on multiple items in a single operation. If any of those operations fail, it rolls the entire thing back, and you don't have to worry about managing sagas or complex workflows yourself. You can do that with transactions. Really simplified a lot of access patterns. And then the real blockbuster was this on-demand billing, where you don't even have to provision your capacity at all anymore. You just pay for it per use, just like you would with your Lambda function or your S3 objects or your SNS or SQS, any of that, all on-demand billing, which is just amazing that they can do that from a database. You pay for individual reads and writes directly. So this was a really big game changer, especially in the serverless world where you really want that pay-per-use billing model in sort of all that you're doing. And then a couple other changes they made last year, instant adaptive capacity. So we talked about adaptive capacity that used to take 20 or 30 minutes to do. They changed it to its instant. So they're just, whatever capacity you provision, it's sort of going to your most used item instantly, which is pretty awesome. September last year, they released this NoSQL Workbench. It's just a nice data modeling tool to help you model your data in DynamoDB. And I've got a bunch of screenshots in this talk using NoSQL Workbench. It's all throughout the book as well. And then last year, November, right around reInvent time, they had adaptive capacity on individual items. This is pretty amazing. If you have, individual items that are really accessed really hot, imagine like Reddit or Twitter or certain things that have, a really skewed access pattern, they can isolate those for you so it's not, causing noisy neighbor issues with your other data. So really making, if you just look at this is just in the last 3 years. I can't wait to see what they come out with every event here in 2 months as well. But they just continued to move it forward in terms of feature development that way. So these are the 3 big reasons I'm really loving Dynamo still, all in on it, and really don't look elsewhere right now for databases. But one thing I will say is modeling with DynamoDB is quite different than other databases. And Dynamo tries to tell you a lot about this. If you look at their documentation, they have a lot about how NoSQL design is different. One thing they say, is you should maintain as few tables as possible in your DynamoDB application, maybe as few as 1 table. And this is pretty different for people. Like, what does this whole single table design thing mean? And that's what we're going to get into a little bit in this talk, is just what are some DynamoDB best practices? What do I need to understand if I'm going to start modeling my data with DynamoDB, especially if I'm coming from a relational world? How does that change for me? So that's what I want to talk about here today in this talk. We're going to cover 3 things here. We're going to get started with DynamoDB basics. So just get us on the same page with vocabularies, terminology. That way, just understand what are the key concepts in DynamoDB. And then we're going to move into what I call SQL versus NoSQL, because a lot of people come from this SQL relational background and they understand how that works. I want to talk about how Dynamo is different, why it's different, why they're sort of making the choices that they've made. And then because of those choices, because of those differences, how you need to approach modeling differently. And I think that's really a useful exercise for sort of building out your mental model so you understand how this is different. And then to bring it back down to earth, we cover how to model one-to-many relationships with DynamoDB. And I think that's a really interesting thing to bring it back down and let you understand what you're trying to do with Dynamo. So who am I? I'm Alex Debris. Thanks for the introduction up front. Happy to be here. I wrote the DynamoDB book, talk about on the next slide. I also created DynamoDBguide.com, which is just a free resource out there. If you want to learn more about DynamoDB, go check that out. I'm an AWS data hero doing my work with Dynamo, just an overall AWS and serverless fan. And I'm an engineer at Steady. We're doing a lot of interesting things there. So if you're looking, hit me up and we'll talk. In terms of the book, just push the book real quick. It's called the DynamoDB book. It's the most comprehensive guide out there to data modeling with DynamoDB. It's 450 pages and it's got some extras in there too, depending on the package. It talks about relationships like we're going to do in this talk, but it also talks about sorting and filtering and uniqueness and all sorts of stuff. And then it has 5 walkthrough examples, and these are pretty in-depth examples to show how to do that single table design. So we walk through, how to model GitHub, with users and organizations and repos and issues and pull requests and all this stuff. We show how to do that. So go check that out. That's at dynamodbbook.com. So yeah, introductions aside, let's get into the basics of DynamoDB. And I just want to again talk about vocabulary and key concepts, just so we're on the same page about what sort of matters here as we talk about this stuff. So 4 key concepts, key terms I want to talk about. That's table, item, primary key, and attribute. We're going to do this by way of an example. So you can think of like maybe some users in your application. You want to keep track of users in your application. What would that look like? That's what we'll have for our example here. So here we go. I've got 4 users in my database here. One is me, myself, Alex Debris, and I've also got a few people from Amazon. So I've got Jeff Bezos, I've got Jeff Barr, and I've got Werner Vogels as well. If you look at all of this data together, that's going to be called a table. So all of my records together are going to be called a table. That's similar in some ways to a table in a relational database or to a collection in MongoDB, different in other ways as well. If you look at an individual record in that table, That's going to be called an item. So I've outlined there that record for Alex Debris, that user, that's myself. That's going to be called an item. So that's going to be similar to a row in a relational database, a document in DynamoDB. Items is sort of a key unit there. Now, when you create your table in DynamoDB, you're going to have to specify what's called a primary key on your table. And every item you write into that table must have your primary key. So here we've got this primary key of username. Now, every single item you write into your table needs to be uniquely identified by that primary key. So you can't have multiple items that have the same primary key. They would just sort of overwrite each other if you tried to do that. So here, again, using that username as that primary key, that's a good unique attribute, right? Because you don't want to have users with the same username. So that's a way to have a unique one there for that primary key. In addition to that primary key, I also have attributes. These are other pieces of data I can put on my items. So they would be comparable to columns in a relational database. The big difference here is, with a relational database, you're going to declare those columns up front. You're going to say the name of the column, the type, whether it's required, what the default value is, things like that. That's not going to be true for Dynamo. With Dynamo, you only declare those primary key attributes. Those ones are required. But these other attributes, they aren't required. And that's why you often hear Dynamo called a schemaless database. And that's true as far as it goes, in the sense that, DynamoDB itself is not going to enforce your schema. So it's schemaless in that way, but you want to make sure you have a schema in your database. The difference here is, or in your application, the difference is that that schema, that validation requirement, that's all moved down into your application layer rather than your database layer. I want to talk a little bit further about primary keys. We talked about them a little bit before, and say how you declare them on your table and they uniquely identify your items. Primary keys are very important to how you model data in DynamoDB, so it's very useful to understand them. There are two types of primary keys. So the first one is called a simple primary key. This has just a partition key. And the second type is a composite primary key. This is a partition key and a sort key. So let's walk through the examples here. Let's go back to what we've already seen with our users table, and that used a simple primary key, right? That primary key had one element. It was that partition key of username that uniquely identified each item. If you want, this is really good for sort of key value like access patterns, where you're getting one item at a time, directly finding it by that primary key. But if you're doing anything more complex, if you're doing applications with relations or multiple different types of items, you're often going to use a composite primary key, and that's what we have here. I have this same data here, but what I've done, I've added a employer for each item in this table. So let's say I'm grouping users by employer. So here I have Debris, or Alex Debris. I work for Debris LLC. That's my entity that I own. And then there's also Amazon Inc., right, where Jeff Barr, Jeff Bezos, and Werner, they all work for Amazon Inc. And so with this, we have a composite primary key that has those two elements. That primary key, it has the partition key, which is the employer, and then it has the sort key, which is the username. And I mentioned before that primary key needs to uniquely identify each item. Notice that it's the combination of those two elements that uniquely identifies each item in there. So you can see down below there, I've got 3 different items that all have the same partition key of Amazon Inc., but they have different usernames, so that's okay. It's the combination of that employer and that username that makes it unique. And again, this composite primary key, that's most of what we're going to be talking about, and really where the real data modeling comes in, because that's where you can do more interesting patterns with Dynamo. Cool. So with those basics down, I want to talk a little bit about what I call SQL versus NoSQL. Again, this is going to help sort of orient, for those of you coming from a SQL background, how is NoSQL different? How is DynamoDB different? What are the things that they're trying to do, and what are the things that sort of take away or change about SQL to make this work? And before we get into this, I like to talk about what I call DynamoDB's guiding principle. And this isn't written down anywhere. This isn't stated by Amazon in their docs. But as I understand DynamoDB and understand the features they do add and they don't add, I think this is what guides everything they do. And basically, they do not even want to allow operations that won't scale. So if there's something that might help users and would be useful at 1 gig or 10 gig, but it's not going to work when your data hits 100 gig, they don't even want to let you sort of use it and shoot yourself in the foot with it and wind up in a bad place later on. And again, they want to have this performance curve that we talked later on, where that performance curve is flat. It doesn't matter how big your data size is. You're going to get basically the same performance in DynamoDB and on your local instance as you do in a production application with 10 terabytes of data. So given that, they have that guiding principle of not allowing operations that won't scale well. So I think there are two big decisions that Dynamo made to make that work. And number one is the importance of primary keys. So if we go back to that example we had before with that composite primary key, right, where we're showing both the employer and the username, we've got those items in our table. When you want to access this data, you can query based off these primary key elements. So it's very easy for me to go to this table and say, hey, give me that record for Alex Debris and Debris LLC. Tell me everything about Alex Debris. Or, you know what, give me all the users that work for Amazon Inc. That's a very quick thing to do. But you don't want to query with your other attributes, right? Your freeform attributes that aren't declared in the schema, that are just sort of freeform data. So you can't go to this table and say, hey, give me the user whose last name is Bezos, or give me the person whose email is, jeff2@amazon.com. You can't do that based on the way this table is set up, because it's really oriented around that primary key. And that really helps with scaling. We'll see that in a second. We'll also talk about ways to sort of work around this if you do have multiple access patterns on your data. So number one, the importance of primary keys, very important in SQL, and this is in NoSQL, sorry, and this is very different from SQL, right, where you can sort of add indexes, you can query off any attribute you want. That's not going to be the case in DynamoDB. The second part about NoSQL and about Dynamo is there's no join operation, right? So in this relational database, you're used to having multiple different tables. You have your customers and you have your orders, and you join that together to assemble your data set. That's not going to happen in DynamoDB. There is no join operation. I want to talk about why that happens and sort of what's underlying DynamoDB. So, when I first started learning about Dynamo and wondered how it worked, I always pictured it as like this giant supercomputer that they figured out how to make it really fast, and that's how it worked. So I pictured this giant blob of Dynamo, right, that's working. But that's not actually what's going on here. What's happening is, sort of DynamoDB itself is a facade, and behind the scenes, they have different partitions that are storing your data. So when you write data up to them, they're putting on different partitions. Each of these partitions is going to hold maybe up to 10 gigabytes of data, and then they'll add more partitions as they need to. You don't need to know about partitions actually to work with DynamoDB, but I think it helps build out your mental model. So that's why I'm talking about this here. So let's imagine our table has two partitions. I want to talk about what happens when a request comes into DynamoDB. So let's look at this on the front end. Let's say we're doing a put item request, which is going to write an item into a DynamoDB table. This is going to add Andy Jassy into our table, right? Who's another person that works for Amazon Inc. So they're saying, hey, put item, here's the primary key. The employer is Amazon Inc. That username is Andy Jassy. And now that front end of DynamoDB, which is called the request router, the first thing it's going to do is going to hash that employer value. So it's going to run a hash function on that on Amazon Inc. And then based on the value of that, it's going to figure out which partition it belongs to. So in this case, it hashes Amazon Inc. and it says, okay, that belongs to partition 1, and it's going to go write it down there. The great thing about this is this scales up really well, right? So I have 2 partitions right now, but let's say my data grows and now I have 30 gigs of data. Now I can add a third partition really easily. Or I can add 6 more partitions really easily. But the nice thing is that hash function, that hash and lookup, saying hash this employer and find out which partition it belongs to, that's an O1 operation. That's a constant time operation. So as my data scales from 10 gig to 100 gig to 10 terabytes or whatever, it's still going to be a very efficient one, because that first thing it's doing is, if I have a 10 terabyte table, it's going to hash it, find the partition, and now my 10 terabyte table is shrunk down to a 10 gigabyte table. It's very easy to sort of search around there. And that's why these primary keys are so important and why they want you to query based on those primary keys. So we've got that so far. We know the importance of primary keys. We know that there's no join operation. I want to talk about 4 implications of that, right? They sort of had to take these things away or change about how SQL works to make NoSQL scale really well. What are some implications of that? The first implications are make sure you use and understand what are called secondary indexes. This is a great feature from DynamoDB. Makes it great to work around sort of that first limitation of the importance of primary keys. So I want to show an example of what I'm talking about here. I've got that example table again, and I was talking about how you query with the primary key, but not with the attributes, right? But what if you have an access pattern that says, hey, I want to query off one of those attributes. I want to query off this email. So I want to be able to look up users by email. So what Dynamo lets you do is it allows you to create what are called secondary indexes. And you declare this on a table. You say, here are the attributes in my secondary indexes. And it basically reshapes your data into sort of a copy table that you can access it by a new primary key. So if I declare my secondary index to be on this email attribute, now my secondary index, will look something like this, which has the exact same data here, but the difference is that primary key is now email. So I can look up users by email, and I can get my exact same data for you. And DynamoDB is managing all that for you. So that's secondary indexes. A couple things I want to cover here. What's going on is that data from your base table is copied into that secondary index with a new primary key. So it's just copying that data for you. You don't have to manage it. DynamoDB is handling all that for you. You can use query or scan, which are the two read-based operations on that secondary index. You can read items from this secondary index with that new primary key. Importantly, you can't write directly to that secondary index. All the writes have to go through that base table. So you need to be a little strategic in how you sort of model your table. What's your primary access pattern, especially around writes? That's going to be your base table. And then you can have these sort of read-based views based on using those secondary indexes. Take a quick drink. All right, so that's the first implication we have here. The second implication is you need to know your access patterns in advance. And this is different if you're coming from a relational world. In a relational world, what you do is you maybe build your ERD or your entity relationship diagram that says, here are my different objects in my application, my entities. Here are the lines indicating the relationships between them. Once you've done that, you often take that ERD and sort of ship it to your database, right? And every box becomes a table. And then you manage those relationships via foreign key constraints between your different tables. And then you sort of write your queries after that. That's how you do it in a relational world. In a non-relational world, like with DynamoDB, or sorry, not non-relational, NoSQL world, you want to design your table for your access pattern. So you're going to start the same. You're going to build out your ERD and understand, your different objects and how they relate to each other. But then you want to say, what access patterns do I have on these objects? How am I going to be reading? How am I going to be writing for my application? And once you know that, then you actually design your table for those access patterns specifically, rather than in this generic way. And that helps you overcome that join operation where you don't have this standardized, normalized table, but you actually have a table that's purpose-built for your access patterns. The next implication, this is the weird one. This is what really throws people, but this is where the single table design comes in. You put all items in a single table and use generic attributes for your primary key. I want to walk through an example of what that looks like and sort of walk through it step by step of the basics, just so we get a sense of what I mean with some of this stuff. So the example we're going to do here, this is a SaaS application. Imagine we're building some kind of SaaS application. We have two entities in it. We have organizations and users, right? Because organizations will come and they'll sign up for our SaaS application, and then within those organizations, users will take action, right? So my company might sign up for this application, and they'll invite me to play around in it, and my coworkers as well. So we have organizations and users. I want to show how we model those different entities in a single table using these generic primary keys. We're going to start off with a couple organization entities. So here's my table. I have two items in this table. I have Berkshire Hathaway and I have Facebook. You can see those right there with the organization name. A couple things I want to point out, especially about the primary key. Number one, look at the primary key. I'm using a composite primary key, and notice that I've given the key elements very generic names, right? So I have a partition key whose name is just PK, and I have a sort key whose name is just SK for partition key and sort key. I'm not using something like organization name or username, anything like that. And the reason is I'm going to be storing multiple different types of entities in this table, so they're not all going to have the same types of attributes, right? My user may not have an organization name, just like my organization isn't going to have a username. So I can't use those sorts of values for my primary key. So I'm going to use very generic names and sort of overload these values here. Second thing I want to point out, if you look at the actual values I'm using for these primary key elements, I kind of have this template that I'm using, and I have this prefix on them. So with my organization item, I have the template of ORG for organization hash, and then the organization name, Berkshire, ORG hash Facebook. And when you're actually building out these items in your table, you're saying, here's sort of the pattern I'm going to use to identify these items. It's going to be used for grouping and filtering and sorting and all that sort of stuff. But you're using more sort of generated names rather than actually meaningful names for your primary key values there. So I've got 2 organizations in my table. I want to go on and add a couple of users in here. We've got that now. With this, I still have those 2 organizations in my table. I've just added the users. The users are outlined here in red. So for Berkshire, I have Charlie Munger, I have Warren Buffett. And for Facebook, I have Sheryl Sandberg. A couple things, I guess a couple things I want to note here is notice how the primary key is a little different for the users as compared to the organization, right? Especially if you look at the sort key, they're going to use a pattern of user hash username. So user hash Charlie Munger, user hash Warren Buffett. Also look at the attributes. They're different, right? For an organization, I have organization name and the subscription level, but for users, I have username and I have role, right? So the attributes are different. Again, that's that schemaless nature. I can have different types of items with different types of attributes here. One other concept I want to share here is the notion of an item collection. So I've outlined that here. All items, what an item collection is it refers to all the items that share the same partition key in a table. So in this example, I have this Berkshire item collection where all these 3 items, both the Berkshire organization item and some 2 user items, are all in that Berkshire org hash Berkshire item collection. And this is important again because of what we go back to here about how that DynamoDB front end, that request router, is doing that hashing on that partition key and figuring out which partition it belongs to. So here we were talking about Amazon and Andy Jassy. We can change that. We can do a query and say, hey, do a query operation where the query or the PK, sorry, is org hash Berkshire. And again, it's going to be very efficient at that front end. It's going to say, okay, these items are located on partition key 3. It can go there quickly, find exactly the items I want, and send them back to me. So this is a very efficient operation there. And you're often going to be working with these item collections to sort of group together different items as you need them. Last thing I want to point out there is notice that there are different types of items in this item collection. So I've outlined the entire item collection in red, but then in dark blue, I have that organization item, and then in green, I have those user items, right? So this allows me to, I've pre-joined my data in some way, right? If I needed to join my users with my organization, I've done that by co-locating near each other and using that item collection to group them together. So this is a really powerful pattern. We'll see a little bit more about this in the one-to-many relationship section. So that's a big step right there, I know, and feel free to ask questions on that. But that single table design is very interesting, kind of unique. Last thing I want to talk about is just get comfortable with denormalization. And I think this is a hard part for people that are coming from that relational world, and they learned about normalization in first normal form, second normal form, third normal form. Normalization is great. You need to know when to relax normalization, when you can, when you don't need the benefits of normalization to do good work with a non-relational database. So, so we'll talk about that a little bit as well. So that was SQL versus NoSQL, and gave you a little bit of sort of the conceptual understanding of what this looks like, what these differences are, and how they manifest themselves. I then want to talk about one-to-many relationships. I think this brings it back down to earth a little bit, because I think a lot of people have worked with one-to-many relationships, understand how they work in a relational database. We're going to show how it works with DynamoDB. Before we dig into that, I want to talk about what one-to-many relationships are. This is whenever you have some sort of pattern in your application where there's some sort of parent item that has a lot of related items to it. So a couple examples here might be office with employees, right? You maybe have multiple different offices, and then each office has multiple employees. So there's one office has many employees, one-to-many relationship there. A second example there might be in an e-commerce store on Amazon.com, right? They have lots of different customers. Each customer makes many orders. One customer, many orders there. And then, the example we already saw in our example SaaS application, organization to users. An organization signs up, many users work for that organization and access the application on behalf of that organization. So I want to walk through one-to-many relationships, and really, there are 5 different strategies that I often use with one-to-many relationships. I want to walk through them, figure out when you would use them, give an example, and sort of help you think about, okay, this is how DynamoDB data modeling works. So the first 2 strategies are both denormalization strategies. And the first one is called denormalization plus a complex attribute. So to get started, let's go back to that SaaS application. We have organizations, we have users. We're going to add one more entity here in a relationship. And we're going to say, for each organization, each organization might have multiple payment methods, right? Because an organization signs up for the SaaS application, they have to pay. And maybe they want to have, their main payment method, but another one in case it fails for whatever reason, they don't want to lose access. So we allow them to sign up with 2 or 3 or 4 different payment methods. I'm going to show how we model that and then talk about why I went with this approach. So rather than creating a separate entity, I'm going to do this here. So I got the exact same data here. I've outlined in red this new payment method attribute that I'm attaching to the organization items. And it's kind of cramped here to see, but if you look at the attribute value there on that payment method, it's a map. So it's like making a dictionary if you're using Python, or a map in most programming language where you can store multiple values here. And I'm just storing each of those different payment methods on that organization item itself. And this violates all the rules of normalization, right? Because with normalization, you want to have each value be atomic. So you want to break it down. In this example, you split out another table and sort of relate them to each other in different ways. But we're not going to do that here. We're just going to keep it all together. So when should you use denormalization and a complex attribute? This is good when two things are true. Number one, you don't have an access pattern on that related item directly. So on that related item, which here is that payment method, I'm never going to say, hey, I have this credit card or I have this bank account number, figure out which organization it belongs to. The only time I'm really going to mess with these payment methods is like within the context of that organization. Maybe they're in their settings page and they want to see their configured payment methods or something like that. We can help them. We can access, that's within the context of the organization. We can say, hey, go fetch all their payment methods and show it to them and things like that. The other time is, the end of the month when it's time to bill them. And I say, okay, go look up Berkshire or Facebook and pull their payment methods and charge them, right? And we can do that totally. That's within the context of the organization as well. So we don't have an access pattern on that related item directly. It's always in the context of that parent item. The second thing you need to think about there is when you have a limited number of related items, because DynamoDB items have a 400 kilobyte limit, which is pretty large. But if you had some sort of relation that was unbounded, you wouldn't want to just store it on that item itself, because you wouldn't want to run into a limit there. And the example I give here is, we talked about customers and orders like in an e-commerce application. Think of Amazon.com. If they stored all the orders on that a customer directly, and sometime, after 3 years, they made a bunch of orders and they say, oh, you've hit your item limit. We can't store any more orders for you. Now you have to reject all orders going forward for them. That would just be a bad situation. So you don't want to do that if you have sort of an unbounded number of related items. In this case, it's very reasonable for you to say, hey, you can store 2 or 3 or 4 payment methods, but you can't store 3,000 because that's just unreasonable. So that's when that denormalization and complex attribute is a good pattern. You can take a breath. All right. Second strategy. This is another denormalization strategy, and this is denormalization and duplication. We're going to duplicate some of that data, which usually is a bad word when you're talking about relational database and normalization, but we're going to show why it's useful here. So the example here is maybe I'm running a bookstore or a library, and I want to keep track of all my books in here. The primary key I'm using here is a partition key of author name and a sort key of book name, right? And there's a one-to-many relationship there because an author can have multiple books, one-to-many relationship, author to books. You can see I've got 2 books by Stephen King here, and I've got 1 by J.K. Rowling. When I'm looking up those individual books, I might want to know something about the author itself, maybe the author name, but even something like the author birth date, right? And that's something about the parent item that I'm fetching in the context of that related item. That's something you'd usually use a join for in a relational database, but we don't have joins here. So what we're going to do is just duplicate that information. We're going to write author birth date on every single item by Stephen King. We're going to write it on every single item by J.K. Rowling, and every single book we do, we're going to put the author's birth date on. And we're duplicating that data. And again, in a relational database, you don't want to do that because you're worried about, data integrity, things like that. Let's talk about when denormalization and duplication is a good strategy. So this is good when the duplicated data is immutable. One thing about the reason relational databases don't want you to duplicate data is because if you ever need to change it, now you need to go find it in all those scattered places and change it and make sure you have it correct, or else you've got data integrity issues. However, if that data is something that's immutable, that's not going to change, it's not as big of an issue. And for example, here, Stephen King's birthday is not going to change. It's going to be the same today as it was yesterday, and it'll be the same tomorrow. So we're not too worried about duplicating that data across multiple items. Now, there could be situations where that duplicated does change, but it doesn't change very often, or it's just not replicated very much. Maybe you replicate it across 3 or 4 or 5 items, but you don't have it replicated across 1,000 items. And even if it does change, it's very easy for you to go find those 3 items and change it. So at that point, it becomes more of a balancing act of saying, how much does this data change? If it does change, then maybe I don't want to duplicate it and I want to use a different strategy. You can sort of make that decision there. Those are the factors to consider with duplication. So those first two strategies, both about denormalization. This third strategy is the composite primary key and the query. And this is a strategy we already looked at a little bit, so I'll kind of breeze through it. But we talked about in that SaaS application how we have organizations and users, and sometimes we want that join. Maybe we're getting all the users, but we need some information about that organization itself. What we're doing there is we're co-locating it, putting them in the same item collection, using that composite primary key, and then using the query based on that partition key to get the whole item collection, get both the organization item and all the related user items as well. Our data is pre-joined. It's a very efficient query. And you basically get all the benefits of a join without sort of the performance downsides that you would get in a relational join. So I'd say that's a very common pattern for one-to-many relationships, using that composite primary key plus the query. A second and sort of related pattern is to use a secondary index in a query. And let's just expand that last example and talk more about that. Let's imagine our SaaS application is something that has like tickets, right? Where users can create tickets. Maybe it's like a Zendesk application where each user is assigned tickets, things like that. And we have an access pattern where we want to get all the tickets for a user, but also get that user as well. So what you might think to do is do something like this, where you add the tickets in right under their user within that organization there. And you can see I've added a few Charlie Munger tickets in there. And now if you look right there, I could do this query where I had this partition key. I did a query and I said, hey, give me the org hash Berkshire partition key. I could add some conditions on my sort key to give me just Charlie Munger and his tickets as well. And that would give me this item collection with that Charlie Munger user item and his two related ticket items as well. Very efficient query, and that seems great, right? You're using that pattern we just talked about. However, we need to go back to this access pattern. We still care about this access pattern where we want to get the organization and all the users in that organization. If we go back to what we've done with our tickets thrown in there now we've sort of scattered our items before, and we've messed up our original access pattern of getting an organization and all the users for that organization. So we have to read a bunch of other items. We have to read all these ticket items in between that we don't care about. So it's kind of going to blow up that access pattern. So we actually don't want to do that. Given that we already have this pre-existing access pattern, we want to make sure we can handle this new one in a different way. So what we're going to do instead is I'm going to still have these ticket items. They're going to be down here at the bottom in my base table. They'll just be sort of out of the way where I can do basic access based on that ticket ID. But in addition to that access pattern, I've also added these GSI attributes, and this stands for Global Secondary Index. So we talked about secondary indexes where you can sort of reshape your data. I've added these attributes. I've added this secondary index using these GSI1 PK, GSI1 SK values there. And I've added those to both my user items and my ticket items. And one thing I want to point out is that if you look on that Charlie Munger user that we already talked about, and then the two tickets that belong to Charlie Munger, notice that in the base table, they're sort of scattered all over the place, but they have the same value for that GSI1 PK. And that's going to be important when we go look at our secondary index. It's going to be reshaped like this, and then boom, right there, they all have the same partition key in that secondary index, and you can grab all of those together. That's going to get that same item collection. We've got that user item. We've got those ticket items right there. It's going to be a nice, efficient join query. So we're using that same concept of that item collection of pre-joining our data, but we're doing it in a secondary index rather than our base table. So that's a good pattern for when the primary key is used for something else. You're already using the base table, the composite primary key for something else, so you need to use a secondary index to handle an additional pattern, but in a similar way. All right, last strategy I want to talk about. This one's a little more rare, but it's kind of interesting, and I like showing it just because I think it can help get your sort of juices flowing on how to model some of this stuff. And this is called the composite sort key. And you can imagine you might have data that has sort of multiple different relationships, like levels of relationships. So the example I like to do is imagine like stores across different countries. So imagine like Starbucks, right? It has stores in all these different countries, and maybe you have different access patterns. Maybe sometimes you want to get all the stores in a particular country. So I could do that here. If my partition key is country, I could get that by getting all the countries in the USA by doing this. But then I also set it up with this sort key that's jamming a couple different values together. It's doing state, hash, city, hash, zip code, hash, and then the store ID. And that allows me to search at lots of different levels. So if I want to get all the stores in a particular state, I can say, hey, give me the ones where the partition key, the country is USA, and the sort key starts with NY, right? And that would give me all the New York Starbucks stores really quickly and efficiently. Or maybe I want to get even more granular than that, and I say, not just in New York, but actually in New York City, New York. And I could say my sort key starts with NY hash New York City. And now I can get just those 2 New York City stores really efficiently. Or maybe I want to get even more specific than that. I want to get down to the specific zip code, right? And I want to say, hey, give me all the Starbucks in the USA that are in New York State, New York City, 10019 zip code. That's going to get me this one right here and get down to that. So the great thing about this is I can sort of search at multiple levels of granularity. I can search at that country level. I can search at the state level, the city level, the zip level, all the way down there with one sort of pattern there. So this is that composite sort key. This is good when you have multiple different levels of hierarchy, right? We had country, state, city, zip, all different ones, and we want to search at different ones at different times. But also when I'm searching at a level in the hierarchy, I want all the sub items. So if I'm searching within a state, I want to get everything below that all the way down to the zip code level. Whereas, when I was talking about that SaaS application with organizations, users, and tickets, sometimes I want to search organization and users, but I don't want to get tickets there too. So I don't want to get all the sub items in that hierarchy. I just want to get organizations and users. So this works when you want to go all the way down, no matter which level you're searching at. So those are the 5 strategies for one-to-many relationships. Very different. I think the interesting part about this as compared to a relational database is you really need to know your access patterns and your needs and the context around that to make the right choice on sort of what strategy you want to use. Just a quick summary on what we talked about here. Three big things we went over. Number 1, DynamoDB basics. We talked about vocabulary, terminology, got on the same page with some of that stuff, and then talked about SQL versus NoSQL and what are the sort of conceptual differences if you're moving from a SQL relational database into this NoSQL database, DynamoDB. What are their goals? What are they taking away? And what are the implications of that for you? And then to bring it back home, we talked about one-to-many relationships, 5 different strategies for handling these one-to-many relationships and different things you can do there. So hope that was helpful to you all. Again, happy to answer questions at all, either in this chat right here, or I'm very available on Twitter, email, all that stuff. I'm pretty findable out there. So just look me up, Alex Debris. Thanks for having me.
Thanks to you, Alex. We have very interesting questions. Yeah. Maybe the first one is related to how does DynamoDB approaches to reactive programming? Maybe about the DynamoDB streams and how to decouple application, or maybe Lambda. Could you tell us something about it?
Mm-hmm. Yeah, so I don't know a ton about reactive programming. One thing I can say with Dynamo is you can enable a feature on DynamoDB called DynamoDB streams. And what this does is it basically gives you a change log for your DynamoDB table. And every time you make a write operation into your table, it's going to drop an item into that stream that's going to say, hey, this item was created, or this item was updated, or this item was deleted. And then you can process that stream. And that stream is going to be like a Kafka stream or an AWS Kinesis stream, any of that stuff. You can process that in order, and you can update downstream systems. You can send out pub sub messages to SNS if you want to sort of fan that out across your architecture. You can update analytics, anything you want to do with that, which is really cool. It sort of gives you out of the box change log for your database.
Totally. And the strong point is that it's an ordered sequence of events. That's really cool.
Yep.
Another question really interesting here from the Peruvian community, it's that when to choose DynamoDB over DocumentDB?
DocumentDB. Okay. Yeah, that's a good question. I would say, so DocumentDB is basically a MongoDB compatible database. So it's, Mongo versus DynamoDB. I would say MongoDB out of the box gives you more flexibility on query. You can, querying and indexing. You can do a lot more flexible queries on DocumentDB. DynamoDB is a little more restrictive in some of that aspects. The problem I would say is if you use those more flexible queries, whether that's search indexing arrays or geospatial or different things like that, a lot of those don't scale up super well. So they might work well if you're sort of in a low scale environment, but then again, Dynamo really cares about being able to scale up really high, so they don't want to give you features that won't scale, and some of those Mongo features won't scale very well. So that's the first thing. The other thing I would say is Mongo and even Document is going to be a little more. A little bit more maintenance burden, even the fully managed ones. It's more of a server-based infrastructure where you do have servers, and DocumentDB does a good job of sort of managing all that for you. But with DynamoDB, you don't think anything about sort of server instances or anything like that, or even upgrading your versions. Like DynamoDB is a service, just like SQS or S3 or anything like that, and you really don't worry about some of that stuff. So I just really like the sort of ops burden and the things they can give you, like pay-per-use pricing, things like that.
Great. And the third and final question is, what happens if you miss an access pattern and you need to change or update that access pattern? Maybe it's more focused like an EMR task, or how would you migrate those data to a new table or a new structure?
Yeah, that's a great question. I feel like people really do worry about that, especially when I say know your access patterns in advance. It's not realistic because your patterns do change. I actually think it's not that bad to change your access patterns. It's when I say that stuff, it's more that you're designing your table for your patterns, but you can update them later on. It depends on what kind of new access pattern you're adding. If you're adding a totally new type of item into your table, that's going to be pretty easy because you just sort of model out how that looks. You update your application code. You don't need to change any existing items to make that work. The harder ones are like, if you already have some existing items and now you need to access them in a new way, and maybe you need to decorate them with some new global secondary index attributes to index them correctly. That's some sort of basically like an ETL operation, like you're saying, with EMR or something else to decorate those existing items. And that's a little bit of a process, but it's also pretty mechanical, I would say, in terms of like once you've done one or two, you figure out what it looks like. And if you look in the book, I've got a whole chapter on migration strategies to understand what kind of migration you're looking at and what that means in terms of actually making that happen. But I've also got I talked about 5 walkthrough chapters. We actually have 2 of the chapters are on the same thing. It's starting with GitHub and modeling a bunch of stuff, and then it's saying, okay, we did all that. Next chapter is imagine we're 6 months, a year down the line, and you have this new feature, this new feature, this new feature. How do I add those into my existing table? We talk about how that migration sort of works and walk you through that as well. So I used to be scared of this until I sort of really dug into it. I think it's not as bad as I used to think.
Awesome. We have many questions regarding integrity, transactions, consistency. Maybe we are running out of time, so our recommendation would be that maybe if you are interested into more advanced and basic patterns of DynamoDB, go and buy the book. So this is great. We have a giveaway today. So Alex, it would be awesome if you could make one question for the audience, and the first to write will be winning the coupons for your book.
Okay. Sorry, I should have thought of this ahead of time.
It has to be something about your talk.
Yeah, for sure. I definitely want to do that. What does I talked about how DynamoDB scales, and actually I don't want to do that one. Sorry. Let's just say name 2 of the one-to-many relationship patterns. If you can do that.
Oh, great. Ok, nombrar 2 de los patrones principales que se hablaron hoy para DynamoDB. Las primeras 2 respuestas se llevan el código para el libro. It scales on demand, is that right?
Sorry, the one-to-many relationship patterns. I talked about the 5 patterns. If they could name, I could probably maybe just name one of those. There we go. There's one. Denormalization
complex attribute.
Yep.
Congratulations.
That's great.
And I think, how about this?
Primary key and query. Yep, composite primary key and query. Yep, that's pretty good.
Okay, great. Les escribiré directamente para enviarle los códigos. Muchas felicidades. Alex, thank you so much for having this conversation with us. It's really insightful. And we hope to see you again here with the AWS groups. Thank you so much for your time.
Hey, thank you, Gabriel. I love it. Great questions. If anyone has questions, feel free to reach out on Twitter. I'm happy to help or email any of that stuff. Great. Thanks for showing up, everyone.
Thanks to you. See you.
See ya.
Listo. Muchísimas gracias a todos por seguirnos. Estuvo súper buena esta sesión. Creo que hablar de bases de datos siempre es un tema bien importante y donde todo el mundo tiene dudas. Así que Si pueden postearnos aquí sus comentarios, ¿qué más quieren aprender de DynamoDB? ¿Qué otro tipo de bases de datos? Creo que sería súper interesante para programar los siguientes meetups. Y bueno, muchas gracias. Todavía seguimos aquí pendientes. Mándenos un susurro en Twitch para mandarle los códigos. Me parece que las 2 personas fueron de Twitch, entonces todavía no cerramos el stream. Dejo una pantalla para podernos escribir. Y pues muchas gracias. Gracias, Eloy, por acompañarnos.
Gracias, Gabriel, y espero que les haya gustado la plática. Nos contactamos con las personas ganadoras en Twitch.
Exacto. Muchísimas gracias. Buenas noches a todos.
Buenas noches.
Hasta luego.